Right, so we need to talk about what just happened in AI because honestly, the past few weeks have been absolutely wild. We've got Anthropic dropping something called Bloom that's completely changing how we test AI behavior. Google releasing T5 Gemma 2 that actually reads before it responds. NVIDIA pushing out Nemotron 3 for serious multi-agent work. And Mistral finally cracking the code on making messy documents useful. Let's dive in. So Anthropic just open-sourced Bloom, and this is genuinely fascinating. It's not about testing how smart a model is or how fast it answers questions. It's about understanding how AI actually behaves when you put it through longer, more realistic situations. And this matters way more than you might think. Here's the thing. Models are getting really good at looking polished in short demos. They're polite, they follow instructions perfectly. They sound great in those clean little test scenarios. But the weird stuff only shows up when tasks stretch out over time. Maybe the AI starts agreeing with everything a bit too much. Maybe it quietly protects itself instead of being honest. Maybe it drifts away from what you actually wanted, and you only notice after dozens of turns. Until now, catching that kind of behavior was incredibly manual. Researchers had to dream up scenarios, write prompts, run endless conversations, read through massive transcripts, then argue about how to score everything. And as models evolved, those tests got outdated fast. Bloom automates the whole thing. You give it one behavior definition, and it generates entire test suites automatically. Different scenarios every time, but measuring the same underlying behavior. So the model faces situations it's never seen before. But researchers can still compare results consistently. It uses multiple AI agents working together. One studies what the behavior actually looks like in practice. Another creates realistic scenarios where it might appear. Another runs those tests. Then judge agents score what happened. Anthropic tested this across 16 frontier models, with 100 scenarios each. And it even caught intentionally broken models almost every time. The automated judges matched human judgment really well, especially on the cases that actually matter. This is where AI safety stops being theoretical and starts being practical. Now Google's T5 Gemma 2 is taking a completely different approach. Most models today are optimized to respond instantly. They're brilliant at producing quick answers, but they struggle when you give them a ton of material and expect them to actually understand it all. Long documents, mixed inputs, reports with charts and images, places where missing one detail breaks everything. T5 Gemma 2 fixes this with a simple idea. Let the model fully process everything first, then generate output based on that understanding. That's why they went with an encoder-decoder architecture. The encoder takes everything in and builds a complete picture. Then the decoder works from that picture instead of juggling input and generation simultaneously. This is huge for real-world applications. Internal search tools, document analysis, legal files, technical specs. Anywhere skipping a paragraph isn't just a minor error, but actually breaks the entire task. Google released 3 sizes, from 270 million parameters up to 4 billion. And they're designed to handle text and images together across over 140 languages. What's clever is they didn't start from scratch. They initialized from pre-trained Gemma checkpoints and refined from there. The whole system is built to understand before responding. Not because it sounds impressive, but because too many systems right now fail by skimming instead of reading. Then NVIDIA dropped Nemotron 3, and this one's built for long-running multi-agent setups. 3 versions ranging from about 32 billion parameters up to 500 billion. But here's the trick. Only a fraction of those parameters activate at any moment. The smallest version uses just 3.2 billion parameters per token. You get massive model capacity without paying the full compute cost every step. It mixes different architectural approaches. Mamba blocks for efficient sequence modeling, attention where reasoning matters, and sparse expert layers for specialization. The system can handle up to 1 million tokens of shared memory, which means these AI agents can coordinate over very long workflows without constantly losing context. This is where multi-agent AI stops being a demo and becomes actually practical. And finally, Mistral released OCR3, which solves a problem everyone's been dealing with quietly. Most important data still lives in messy PDFs, scans, forms, handwritten notes. Bad OCR breaks everything downstream. OCR3 handles forms with boxes, low-quality scans, handwritten text mixed with print, and especially tables that usually fall apart. It beat the previous version about 74% of the time on real business documents and outputs proper structured formats instead of walls of text. The pricing makes large-scale document processing actually affordable at $2 per 10,000 pages, or $1 with batch processing. It removes one of the biggest friction points between real-world data and AI systems, and that's exactly why it matters. So yeah, AI is clearly moving toward longer tasks, deeper workflows, and more autonomy. These aren't incremental updates. These are foundational shifts in how AI systems operate. What are your thoughts on where this is all heading? Drop a comment below, and let's discuss it. Make sure to subscribe if you want more breakdowns like this. Thanks for watching, and I'll catch you in the next one.